Hey. All right. Sorry I'm not there today. Not feeling so well. Still running a fever. Don't want to get any of you guys sick, but I also don't want you to miss out on this wonderful opportunity, wonderful opportunity to learn. So let's get to it. Today, it's all about relative frequency of simple events. All right. Relative frequency, kind of a simple concept. All it is we count up the number of favorable outcomes, the one you're looking for, and you divide it by the number of total outcomes, or the total number of outcomes, and that is your relative frequency. So let's review here. This is a good thing to kind of highlight some things. Probability is the chance that an event will occur. A simple event is one outcome or a collection of outcomes. For example, an event can occur when tossing a coin, spinning a spinner, or choosing a card at random from a stack of cards. When you perform one of these tasks, you are conducting one trial of a probability experiment. A simple event would be like, okay, getting a heads when you're flipping a coin, or rolling a 2 when you roll a die. Okay, that's what a simple event is. All right. Anyway, you can use the results of a probability experiment to compare the number of favorable outcomes to the number of total outcomes, and this is what we call the relative frequency. All right, so it's just a ratio, and these ratios we can write as fractions, decimals, or we can write them as percents. So let's roll. All right, here's an example here. Lewis, you don't have to read all this, I'll tell you about it. Lewis's fruit star data. He's reaching into a bag of fruit stars, and he's pulling them out and recording the results. Well, this is his little table of frequency data. All right, he pulled out 25 watermelon fruit stars, 36 strawberry, and 19 mango. All right, so right here it says based on Lewis's results, what is the relative frequency of selecting a strawberry star? All right, well, first we write the ratio. How many total strawberries were drawn? 36. How many total fruit stars? Well, if you read this, it said 80 times here, but how else could you get it? You could just add up the frequency data from the table. Add these up, you get 80 total times he pulled out a fruit star, and it comes to 36/80ths. Now we simplify that ratio, and then we can also write it as a fraction or decimal. Some of you will just type it into a calculator, divide the top by the bottom, and get the decimal, and then convert that to a percent. But we can also make a denominator of 10, 100, 1,000, any power of 10. That's easy to use to turn it into a decimal easily, and then turn it to a percent. Okay, so we are finding our relative frequency, and then we're writing it in different forms. Example 1 here, it says here, we have a number cube. It's labeled just like a normal number cube or dice is, and it's rolled 20 times. So that's our total number of outcomes, and then the number 5 is rolled 4 times. What is the relative frequency of rolling a 5? Well, our favorable outcome was rolling a 5. How do you know which one? Because it asks us about that one. So we always put the one it asks us about, the results for that one on top. So that's going to be 4 over 20. Simplify it to 1/5. Write it as a decimal or fraction. So 1/5. Some of us already know it's 0.2. Others will have to do the work and get 0.2. And then bump the decimal over twice. That's 20%. And bingo, we're rolling. Okay. So relative frequency, fairly simple idea. All right, we're still rocking relative frequency, but now we're looking at a table and trying to interpret this table and find relative frequencies. So a group of students went to the zoo, and there was a survey about their favorite exhibit. So what is the relative frequency of the favorite exhibit being either penguins or bears? So if we look at penguins or bears, let's see, bears is here, there's 6 people like them, and penguins is 13. So if we total that up, that will be our numerator. And then if we total this whole thing up, that'll be our denominator. So, right, total the whole thing up and total up the 2 that we're looking for, our favorable outcomes, and make that into a fraction here. So 19 over 70, and that 70 doesn't go nicely into any sort of power of 10. So we'll just use the either long division if you want to, or since you have a calculator, just do 19 divided by 70, and it comes to about 0.27, okay, or about 27%. So how did that work? We just total up the frequency data and put that in the denominator, and then total up the ones that were favorable, the ones that the question asks us about, which is bears and penguins, and that becomes our fraction, and we can convert it by division. Moving right along. Okay, so maybe the data will be presented to us in a graph here. All right. Excuse me. So we're going to find the relative frequency of spinning green or blue for this experiment. Express the ratio as a fraction. All right, so we don't have to change it to decimals this time, but let's see. This is telling us the frequency, how many of those occurred in this experiment, and the spin resulted in, let's see, that's 14 reds being spun, 24 greens being spun, and 22 blues being spun. So we've got some work to do, some work to do to figure out the total, but we just have to add up these three. All right, and when we add up 14 and 24, that's 38 plus 22, which gives us that 60 grand total number of spins. All right, and then we add up the two that are in the question, so green or blue. So we add up the 24 and the 22 like they did here, and that's our ratio. Okay, then that simplifies down to 23/30ths. That's our relative frequency. If we had to change it to a decimal, we could just divide to get that decimal answer. Cruising along here. I think things are working out fairly well. Hopefully it's clicking for you, and during the practice you'll be okay. All right, so now we have relative frequency tables and bar graphs. Basically, instead of just having the frequency data, there's going to be either another column, or it might leave out this frequency data altogether, and it will just give you the relative frequency of each thing happening. Relative frequency is basically the percentage that it happened in that in the whatever experiment was done. All right, so this means that 40% of the time someone in this survey had blood type of A, and this means 10% of the time people had blood type B. Okay, notice how if you add these up, it's going to equal one whole or 100%, because this is all the data that was collected. All right, relative frequency versus frequency. Excuse me. All right, so now this little difference here between they're going to call it kind of something different, but it means basically the same thing with one minor difference. But you can see here, experimental probability is the same exact ratio: number of favorable outcomes, total number of outcomes, same exact thing. All right, so if we take this situation, Amelia is presented with two unmarked boxes of the same size. Amelia opens the first box in which there is a present. She opens the second box in which there is no present. The relative frequency of selecting a box with a present inside is 1/2. All right, so now we'll see how relative frequency and experimental probability are different. Well, first, they're the same because you're still going to get that same 1 out of 2 fraction. But what's the difference? Relative frequency is describing an event that has already occurred. Okay, but experimental probability is the chance of an event happening in the future based on what has already occurred or happened. All right, so basically just takes this and then starts to predict using it. So once you start predicting using the relative frequency, we call it experimental probability. Crazy distinction. I'm not sure if it's necessary, but hey. Here we go. All right, so now we're going to find experimental probabilities. So refer to the relative frequency bar graph shown that you saw earlier in this lesson. What is the experimental probability that a person chosen at random from the group will have blood type A or type B. All right, so relative frequency, we're saying, all right, these are already the percentages. So the ones we looked at earlier had just frequency data, but this is the relative frequency data. Okay, so this is already converted to the percentages of how often these occurred in the survey. All right, so A or B. So basically all we have to do is find the relative frequency of the one and add it to the other to get the relative frequency of both. All right, of either or. Okay. The experimental probability has the same ratio as the relative frequency, so the experimental, so we just add them up. And since this one is 0.4 and this one is 0.1, add them up, you get 0.5, and so it's 0.5 or 50%. Okay, this says, what was the so this is a little survey where they asked everybody what was the last gift you received, and here are the results. All right, and then it says, what is the experimental probability that an adult chosen at random will receive a card or clothes? Well, a card is 40%, clothes looks like 28%. So add those up, 68%, boom. All right, so that's simple as that. Moving on. This might be the most difficult part, but it's just a proportion. If you know how to solve proportions, you'll be all set. All right. So we're going to look at someone's relative frequency, a relative frequency in a situation, and then we're going to just use that to predict. So it looks like this player has a career batting average in history. The player with the highest career batting average in history, wow, had 4,189 hits in 11,434 at-bats. All right, so that's the data. All right, total and favorable. And so then it says, based on this, right, how many could he be expected in a season where the player had 500 total at-bats? So basically, we're just making a ratio. All right, so if this is his career numbers, then what should he be expected out of 500? Now, we can kind of estimate what to multiply by, or we can do our cross multiplication. So you can multiply the 500 by 4,189 and then divide it by that, and we should get our number here. Okay, it's just an estimate, so we can round usually and come to a close enough number. And if you read this through, right down here, it just says, one, not even a decimal. They're like 182 or 183 hits. So cross multiply, divide, and get that result. So you use the data here, and then you try to solve and fill in the rest of the proportion. Okay, want to try one? Yes, you do. I'm sure you do. Over the past 5 years, it rained on 1/5 of the days in April. How many days can you expect it to rain in the upcoming April if the weather is expected to be consistent with the past 5 years? All right, so it rained on 1/5, so that's 1 out of 5 days in April. All right, well, I wonder how many days are in April. 30 days, half September, April, June, and November. Okay, 30 days in April. So if we make a simple proportion with 1 out of 5 on one side, and then how many out of 30. This is great drawing, isn't it? Thank you. All right, and then we can solve that. We can do cross multiplication, but this one is just mental math. If we multiply by 6 and multiply by 6, we get 6 out of 30. So 6 days out of 30. All right, hopefully we're feeling pretty good about the lesson. Let me know if you have any questions. It is now time for you guys to try it on.